Hello everyone, let us see another important question. A 30-year-old man is severely dehydrated. His kidneys attempt to conserve the water. So which of the following segments of nephron is primarily responsible for generating the medullary osmotic gradient? So in this question it is given that the patient is dehydrated and wanted to conserve the water. And which of the following is responsible for generating the medullary osmotic gradient? The options are proximal convoluted tubule, descending limb of loop of Henle, ascending limb of loop of Henle, distal convoluted tubule, and collecting duct. The answer here is ascending limb of loop of Henle. So let us see how we came to this answer. So the medullary osmotic gradient is essential for water reabsorption and urine concentration. So this gradient primarily generated by thick ascending loop of Henle, which actually transports the sodium, potassium and chloride into the medullary interstitium, and it is impermeable to water. So when these ions are freely moving and this is not permeable to water, this is actually causing the water. This creates a medulla, allowing the water to be reabsorbed, which is later in the collecting duct under the influence of ADH. So the descending limb of Henle, because it is permeable to water, it does not generate the gradient. It only responds to it. So let us see the incorrect option. The proximal convoluted tubule, it reabsorbs the solutes, almost all the solutes and water equally. So there is no gradient formation. The descending limb, it is permeable to water but not actively create the gradient. The distal convoluted tubule plays a minor role in concentration. The collecting duct, it uses this already formed gradient which is formed by the ascending limb of loop of Henle, and via the ADH it uses the gradient and it does not create the gradient. So the thick ascending limb of loop of Henle generates the medullary gradient by active ion transport, forming the basis of countercurrent multiplication system. So what happens at each level is what we have to see. So this is the diagram which is showing the parts of the nephron, where there will be an efferent arteriole and efferent arteriole, and surrounding the glomerulus there is a Bowman's capsule. From here the proximal convoluted tubule, and then the descending limb of loop of Henle, then the ascending limb which forms a loop of Henle, and distal convoluted tubule and the collecting duct. So what happens in the PCT, that is proximal convoluted tubule, is there is a bulk reabsorption of sodium, glucose, amino acids and water, because they have to be reabsorbed from this tubule into the blood so that the body uses it. If there is no reabsorption, there will be severe loss of all these important electrolytes, glucose, and the patient can get in deficiency. So there is an active reabsorption of most of the things in the proximal convoluted tubule. So next is the descending limb. Here the water reabsorption is majorly taking place. From the tubule into the blood there is a water reabsorption, so there is a concentration of the tubular fluid. If water is gone, the rest of the things will be remaining in solutes, will be remaining in the tubule. That's why there will be a concentrated tubular fluid. Next is ascending limb. As we can see here, the ions are actively reabsorbed into the blood. So the water is still the ions are there and some amount of water is there. The ions are going, so there is a dilution of the fluid in the tubule since the ions are getting lost into the blood. Next, from the tubule into the blood they are going, that's why there is a dilution of the fluid. Next is the distal convoluted tubule. Here the salt and the calcium via the parathyroid hormone are getting reabsorbed. Here there is a fine regulation and happening, there is a balance of the ions. Next is the collecting duct. Here already there is a gradient which is formed, because here the dilution of the fluid is taking place in the ascending limb, and there is some amount of ions are going into the blood by the distal convoluted tubule. This collecting duct with the help of the antidiuretic hormone, it will reabsorb the water and causes final urine concentration. So if there is a loss of this medullary gradient, what happens is the ions will there will be a dilution which is already taking place. Because of this, if any of this process is not happening, there will be a final urinary concentration will not be happening. What happens is, the more amount of water, that is a diluted urine, will be excreted. So because of this, there will be water loss which is more than the solute loss. Hypernatremia occurs, and polydipsia, polyuria will also be occurring. So these are the important points in this question. So the key takeaway point is the medullary osmotic gradient takes place in the ascending limb of loop of Henle. So these are the important